Hey, this is Math Minutes Pro with Dr. Harrison, and today we're going to talk about writing functions. So let's first talk about what a function is, all right? So it's another word for an equation, and in particular, a linear equation, or an equation that has a graph of a straight line that can be represented by a graph of a straight line. So we say a function has a one-to-one relationship between the variable x and y. Now we know that according to this function machine, the x values goes in first, so that's the independent variable. And then you have an equation in here, and your equation could be like what the one we have here, could be something where y equals m times x plus b, all right, which is the slope-intercept equation. And then what comes out is the dependent variable, y. So that means you would substitute a value of x, do the math, and what comes out would be the y value. Remember, x represents the independent variable, y represents the dependent variable. So a function is where you have a one-to-one relationship between x and y, such that if you have a graph, for example, if I draw a vertical line test through this particular linear graph, and if that line hits this green, my vertical line hits this line in one point, we say it is a function. So let's test it out, okay? So if I draw a straight line, okay, notice that that straight line intersects the green line at one point. This proves that that green line is a function, a one-to-one relationship. Where we're going to be writing functions, or we're going to write an equation based on when we are given a set of coordinates. So we're going to write this equation in this form, which is slope. M represents the slope, and B represents the y-intercept. So let me see if I can write that here. I'm going to say that this B is your y-intercept. Just getting a little vocabulary here. And M represents the slope. M is the slope. So don't confuse the slope with x or y, okay? And so now we have defined the parts of that y-intercept. We call it the slope-intercept equation, all right? Why do we call it slope-intercept equation? Because you can easily identify the slope and the y-intercept. And we're going to use our knowledge of what the slope means, which is a change in y. That's delta y over delta x, which means a change in y over change in x. So if you notice, along this line, the y value is changing because it's going up, and the x value is changing because it's going to the right. It'll make more sense once we get started. So we're going to analyze the relationship between the x and y values in these four coordinates, set of coordinates, and then we are going to create a t-table, and then after that we're going to analyze that t-table and use that to write the function or the equation. All right, so you may want to watch this video several times and talk it through. This is conceptual and procedural. So the first thing we want to do is write our t-table. Sometimes the t-table is vertical, but in this case, I'm going to write a horizontal t-table. So let's go ahead and get started with that. I'll make my t-table in blue. So I'm just going to extend that over. Okay. And then we have our x values here and y values here. So looking at the x coordinates, -4, -3, -2, -1. You can write it this way. You can say, okay, -4 for x and y is -1. You can do it like that. Or you can just write all the x coordinates and all the y coordinates. It's up to you. I'm going to write it this way. So here we have -3 and 0. We have -2 and 1 for the y coordinate. We have -1 and 2 for the y coordinate. All right, so then I can erase that extra line. Now, we have taken the set of coordinates and put it into a coordinate plane. I mean, it's not a coordinate. We have taken this set of coordinates and put it into a t-table. Now we want to analyze the relationship and see what's happening. Okay, in order to write this equation in slope-intercept form, I'm just going to, that's my line. We know it has to start off with y equals, right? And let's see if we can determine what the slope is. Well, if you notice, let's look at the change. Let's say we go -4 minus -3. -4 minus a -3. Let me just do that over here. -4 minus -3. That's a minus b. You can rewrite that as -4 plus, what's the opposite of -3? +3. That gives you -1. Okay? So right now we see a change from here to here is -1. Remember, change in y. Okay? And what I'm using over here is a minus b equals a plus the opposite of b. When you have it in a minus b form, change it to a plus the opposite of b. All right, so let's check and see if there's a same kind of change in y. -3 minus -2. Okay, so I'll do the math over here. -3 minus -2, and that equals -3, change the minus to plus, +2, which is -1. We still have a change of -1. And then what about from here to here? Okay, I'm just showing the math. Nice review of subtracting integers. We have -2 minus -1, which is equal to -2. Change the minus to a plus. The opposite of -1 is +1. And we have -1. We have a change in y of -1. So that means that so far, in this case, right, our change in y is -1 so far, right? Now let's see if we can find the change in x. So -1 minus 0 is going to give us what? -1. 0 minus 1 is -1. And then 1 minus 2, just to show you over here, a minus b form, 1 minus 2 is equal to 1 plus -2, which is equal to -1. So we have a constant change in the, we had a constant change in the y value, in the x values. Excuse me, I put that in the wrong place. We were dealing with the x values. That constant change was -1. And now we found a constant change in the y values of -1, right? Okay, so then the slope, -1 divided by -1 is 1. Okay, so I am going to put a 1 there, right? Times x, right? Plus, now, we need to determine what is b, the y-intercept. So let's review what a y-intercept actually is, okay? So a y-intercept technically is a point somewhere on the y-axis. So let's say that this was 3, then the coordinates for this would be, the x value is 0, and the y value is 3. That is the coordinates for the y-intercept. So now we need to find the y-intercept, okay? And what we need to do is we're going to take this equation, substitute, we're going to pick one of these points and substitute x and y and the slope m to calculate b, the y-intercept. All right? So let me show you what I mean when I say that, okay? And we can actually pick any one of these values for x comma y. In this case, I'm going to pick this one because it seems pretty simple. So I put a dot there. So the y value is 0. Substituting, well, first let me write the equation. Y equals m times x plus b. And I substitute y, I substitute 0 for y. And the slope is 1, so substitute 1 for m. And the x value is -3. One times -3 plus b, and I brought the b down. So what did I do? I selected a point and substituted the y value here for y in this equation. The slope is 1, so I substituted 1 for m. And then the x coordinate is -3, so I put -3. So 0 equals 1 times -3 is -3 plus b, right? Solve for b. Add 3 to both sides. Cross that out. We get 3 equals b. Okay, so now we know what the y-intercept is. So then I go ahead and finish the equation, which is b equals 3. So the function that goes with this set of coordinates, if I were to plot them or use the t-table, is y equals x plus 3. Okay, that was quite a bit. So let's review the steps we went through. Okay, we were given a set of 4 coordinates, and we changed it and we rewrote it as a t-table. And we were asked to write a function, so I decided to write the linear equation, which is y equals m times x plus b. And I knew that if I'm going to write my equation in that form, I set it up to where I can plug in values. So then we had to first find out what is the value of the slope. So we found the change in, because the slope means, m means change in y over change in x. Okay? So the change in x values, I went -4 minus -3. That was -1. -3 minus -2, -1. -2 minus -1, -1. It was a constant change for x of -1. So I put -1 there for the change in x. And then we found the change in y. -1 minus 0 is -1. 0 minus 1 is -1. 1 minus 2 is -1. So the change in y values are -1. -1 divided by -1 is +1. So then I put the slope is 1. I put the x there. And initially, I didn't know what the y-intercept was, so I had to calculate that. To find the y-intercept, you write your slope-intercept form equation here, and then you're going to plug in, you need to find b, so you're going to plug in the x, the y value, and the slope. That's why it's good to organize this. Now, we pick a point. I could have picked any one of these points, but I picked the point, which is the same one here, which is -3 and 0, -3, comma 0. Well, the y-intercept is 0, so I substitute 0 for y. The slope is 1, so I substitute 1 for m. And the x-coordinate is -3, so I substitute x for -3, and then I bring down plus b. Now, I'm going to simplify and solve for b. Bring down the 0 equals 1 times -3 is -3 plus b. Now I need to isolate the variable b and solve for b. So I add, instead of subtracting b, I'm going to add 3. Instead of subtracting 3, I'm going to add 3 to both sides of the equation. That crosses out. 0 plus 3 is 3. 3 equals b. But we're not done. That helps us. So now I know what the slope is, and then I know what the y-intercept is, b, so I put 3 right there, and then I just rewrote it. Notice I don't have to write the 1 in front. It's, even though it's there, you don't have to write it in front of the variable. That 1 is the coefficient, but it's also your slope. So watch this video again and do it all over again, all right, because it takes time, all right? So let's go ahead and do one more problem just to give you some extra practice. So I'm going to erase the space. We're going to walk through these points of problem solving again. I'm going to walk through these steps. Okay, so in this particular case, we have a set of 4 coordinates. Let me get those up here. This is number 2. I think I'm going to use a different color. Okay, so we have, this is for number 2. We have 2, comma 3. We have 3, comma 5. We have 4, comma 7. And then we have 5, comma 9. Now, I have seen students do everything right, but write the wrong coordinates. So make sure you copy the problem correctly. In this case, I'm going to check just to make sure. Give me a moment. Okay, everything looks good. Now, let's generate the t-table. This time, I'm going to use a vertical t-table this time, so why not? We used the horizontal t-table, this time we'll use a vertical t-table. So I will set it up like this. These are my x values and my y values. And now I'm going to convert these points and drop them into this t-table. We have a set of x and y coordinates, but let's convert it to an xy t-table. So we have 2, comma 3. We have 3, comma 5. We have 4, comma 7. We have 5, comma 9. You can make your t-table look like this as well. Now, remember, we need to find the slope, which is change in y over change in x. So let me go ahead and erase this part so that we can substitute it. Let's go ahead and find the change in y. Okay. Now, you can also, remember last time we went think we went the first coordinate minus the second, but you can go the second minus the first coordinate. All right, so let's do it this way. This minus that. 5 minus 3 is plus 2. 7 minus 5, that's plus 2. 9 minus 7, that's plus 2. So we have a constant change in y, right? The constant change in y is positive 2. Now, let's go over here. 3 minus 2, that's positive 1. 4 minus 2, positive 1. 5 minus 4, positive 1. So we have a change in the x values of positive 1. Let's put it right there. So 2 over 1, our slope, basically our slope is 2. All right, we know what the slope is. Remember, our goal is to write that function or equation in y equals m times x plus b form, because we have here, when we have points like this, we show that since we have a constant change in y over x, that's a straight line, okay? This represents the rate of change too. All right, now let's go ahead and set up our equation. Okay, we know that y equals, and we know what the slope is. The slope is 2 times x plus, but we don't know the b value. What we're going to do is we're going to rewrite this equation here. Y equals m times x plus b. We're going to substitute y and x and the slope and calculate, find out what b is. We're going to pick a point or coordinate. So I don't know, I'll put a dot here to show that I'm going to pick those x and y values to substitute in here. So the y value is 3, so I substitute 3 for y. And the slope is 2 times the x value is 2 plus b. All right, so let's do the math. 3 equals 2 times 2 is 4 plus b. Okay, solving for b, we subtract 4. We need to get rid of the 4. What's the opposite of adding 4? Subtract 4. Whatever you do to one side, you do to the other side of the equation. That crosses out. 3 plus negative 4 is negative 1, which equals b. We found the slope, but we're not done yet. And we're going to write our final answer. We know what the slope is. We found our y-intercept, which is b. b equals negative 1, so we can put plus a negative 1. And then we're going to write our final answer of the function that represents this set of points. You can write it as y equals 2 times x plus negative 1. But remember, or you can write it as y equals 2 times x. A minus b equals a plus the opposite of b, changing that plus to a minus, and the opposite of negative 1 is positive 1. So this represents our function or equation that represents the set of points. Long problem, I agree, but we took the time to explain it for you. That's how you write a function. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page on my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.